All right, so today's notes are on piecewise functions. Our content objective is to graph, write, and apply piecewise functions, and our language objective is to correctly define and identify piecewise, step, and greatest integer functions. So first thing, piecewise functions. Piecewise functions are functions that have different rules for different parts of their domains. So you may have seen these before, but they jump around, or they can jump around. They can be continuous, discontinuous. It's just going to give you a set of different rules for different parts of it. So instead of being one continuous function like a line, they can jump around and be kind of crazy. So let's jump right into what we're going to be doing with piecewise functions. So we're going to start by graphing them. And to graph them, we're going to be focusing on piecewise functions that are based off of linear functions, since we're doing this in our one variable function unit. So we're going to be doing parts of our graph. We're not going to be including parts like our quadratics or cubics or rational or anything like that, though you could have that in piecewise functions. Today we're going to focus on piecewise functions that are using linear functions in the form y equals mx plus b or slope-intercept form. So the ones we're going to be working with today specifically are focusing on piecewise functions that use multiple linear functions in different parts of their domain. So our first example, we're going to graph this piecewise function. So note that you write f of x, you have a curly bracket, and then you have your different rules, and then the domain intervals that rule applies for. So I'm going to graph 2x when x is greater than or equal to 0. So I'm going to graph each section individually. So I'm going to start with this one. I'm going to start with the endpoint. So here I'm going to start when x is equal to 0. First, is this going to be open or closed? It's going to be closed since it has the equals to line. And then I'm going to plug in the endpoints to the equation. So in this example, the first one, I plug in x equals 0. So I get 2 times 0, which is 0. So my first coordinate point is going to be 0, 0. So I'm just doing this off to the side here. I know it's really small, so if you have trouble seeing it, let me know. I can go over this again in person. My first coordinate point is going to be 0, 0, so I'm going to plot that point here. And then I know the rest of the graph is going to be 2x. Then I'm going to use the slope that's given and my starting point, and I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. And that's going to continue on as long as x is greater than 0. So notice, since it's greater than 0, I was going to the right of 0, going in the positive direction. And then I can graph my line. So I did that first section. Now I'm going to go on to the second section. So this time I have two endpoints. This one has an open circle, and this one has a closed one. So I need to plug in both endpoints for the second rule. So I'm going to do this. I'll label this one 1, move it over here. I'm going to label this part 2, and I'm going to do this down off to the side here. So 2, I'm going to plug in when x is -2 first. So I plug in y equals -1/2. Sorry, I should have written y equals -1/2 times -2. So y -1/2 times -2 is just 1. So -1/2 times -2 is just 1. So my first coordinate point I'm going to have is going to be -2, 1. So bear with me with this spacing, but that's what we're going to do. So I'm going to go to -2, 1, and I can plot that point. It's going to be a closed circle because it has the equals to line at -2. And then I know it's only between here and here, so I'm going to plug in 0 for x to find my other point. So when x equals 0, I get y equals -1/2 times 0, which is just 0. So my next coordinate point is still 0, 0. So these points, I can just connect these lines because I know my endpoints are -2, 1, 0, 0. So for this interval, I just have to connect them, which is convenient. So then for number 3, I'm going to do this one up here. So again, sorry for the mess, but hopefully you're seeing what I'm doing. Again, I'm going to have an open circle, and I'm going to plug in -2 to my equation. So when x is equal to -2, I have y equals -2 plus 3, so y equals 1. So I end up with the coordinate point -2, 1. And that again actually is that same point coincidentally. So I don't need to worry about drawing an open circle because that point already exists on my graph. So then I'm just going to follow my slope. And here my slope is 1. So normally I'd be tempted to go up 1 over 1, but I need to only graph this when x is less than 2. So I know, and if I were to continue, I'm not graphing on this side of the graph, I'm only graphing to the left of -2 since x is less than -2 for this interval. So if it's +1, that again goes up from the left to right. So I'm going to go down 1, down over 1, and that would continue on that way. So then that is my graph. I've successfully sketched it and I'm all set. So I want you to try the next quick check on your own. So pause it if you need to, try it on your own. I'm going to go over it now. So I'm going to start by sketching my coordinate grid. X-axis, y-axis, 1, 2, 3, and then the other way. Sorry. -1, -2, -3. And then I can graph 1, 2, 3. Okay, so first one, I have -x plus 1 for x is greater than 0. So I'll label this one 1. I'll do the work here. So when x equals 0, I get y equals -0 plus 1, which is just 0 plus 1 or 1. So my first coordinate point is going to be 0, 1. So I go to x is 0 and then 1. Here it's just greater than, so it's going to be an open circle. So I have my open circle. And now I have a slope of -1. So I'm going to go down 1 over 1 this way, down 1 over 1 this way, down 1 over 1. So I use my slope here to graph this side, graph my line, and I'm all set. So then I'm going to do number 2. So number 2 starts at 0 as well. So I'm going to start when x equals 0. That's the only endpoint on this section. So then I say y equals 2 times 0 minus 2. So y equals 0 minus 2. Y is equal to -2. So my coordinate point is going to be 0, -2. So I go down here. Again, it's still an open circle. So I'm going to put an open circle there. And this time I have a slope of +2. So I'm going to, I would want to go up this way and over, so I'd want to go up 2 over 1, but since I can't do that, I have to go the other way and go down 1, 2 over 1, and my slope would actually be down this way. So even though it's a positive slope, I still, positive is this way, so I want to make sure my line, the arrow might not be pointing in the negative direction, but if I was looking at it left to right, it'd be going up. So again, I know the slope can be kind of tricky because it's going, your domain is in the negative direction, but you still want to imagine what the line would be doing if it continued upwards from left to right, because that indicates, or that is what the slope, the direction that the slope goes in. All right, I'm going to flip the page. So next example, we're going to write the rules for the piecewise function below. So last time we were given the rules, we graphed it. Now we have to go the other way. So we start by identifying the turns or the change in direction, and that will help us determine our intervals. So I'm going to go left to right. So I notice my first turn is right here, and that's at -2. So I know my first rule is going to be for when x is either less than or equal to -2. It appears to be a closed circle, and there it doesn't, it goes, it's a filled circle, so it doesn't matter which way I put the equals to line, so I'm going to put it there first. So because it actually hits that point and is a closed circle, I can put the equals to line there. So for the next one, I have to start at -2, and since I included it in that last one, I had the equals to line there, I can't include it again. You could put it here and not here, it doesn't matter which one you put this on, but you can only use it once because we want to make sure our graph is indeed a function, not a relation, or not just a relation. So I want to make sure I don't have any points that are counted twice. So since I put it here, I won't put it here, and then I keep going. My next turning point is down here when x is 0. So when x is 0 is going to be my next one. So again, I'll include that 0 point, but that means on my next one, since that's where my next one also starts, I need to not include it. So in this one, x would be greater than 0. So I was going to write 0 is less than x. I'm going to switch that around and write x is greater than 0. So originally I wrote 0 is less than x, but I want to start with the x on the left side. So I'm going to write x is greater than 0. All right, so now I have all my domain intervals. So I need to determine the slope of these different equations. So for this one, I don't know my y-intercept, but I know that my slope is up 2 over 1, because if I count here, up 2 over 1. So I can say it's going to be x, and then I need to figure out where the y-intercept would be. So there's two ways you can do this. I'm going to put a 1 over here again and do this work off to the side. I'm going to choose this coordinate point. So I know this coordinate point is -2, 2. So I'm going to plug this into my graph in slope-intercept form. So again, y equals mx plus b, and I'm going to solve for b. So I can plug in 2 for y equals, my slope is just 1 times -2 for x plus b. So 2 equals -2 plus b. I solve for b, and I get 4. So my equation for number 1 is going to be y equals x plus 4. So x plus 4 is my first rule. All right, so then I'm going to continue on to the next one. Oh, darn it, I messed up the slope. The slope is actually 2. This is -4, so then I add 4. And this is going to be 6. I messed this up as 2x plus 6. I miscounted my slope. I didn't go up 1 over 1. I went up 2 over 1. So please bear with me. This is actually 2x plus 6 because my slope was up 2 over 1. So my slope was 2 over 1, not 1. Sorry, I didn't catch that at first, but please make sure you fix that in your notes. All right, so I'm going to continue on to the next part. So I know my next one has a y-intercept. So in number 2, my second graph, I know that my b is equal to -2 because I can see that that's the y-intercept. I also can count the slope. So for number 2, I know b is -2. I know the slope is also -2. So I didn't even actually have to solve that out. I can just write -2x minus 2. And I already have that graph because I can see it on here. So the last one I have to write, number 3, I again know my y-intercept. B is again -2. And this time m is up 1, 2, 3 over 1. So m is going to be 3. So here I just counted 1, 2, 3 over 1. So m is 3. So I have 3x minus 2 for that interval. And I've successfully written my piecewise function. All right, so last thing we're going to talk about for today is step functions. So step function pairs every number in an interval with a single value. So instead of being one continuous function where it goes up like this, it tells you for this whole interval, so from, in this case, 0 to 1, it's always 0. From 1 to 2, it's always 1. From 2 to 3, it's always 2. So it's just a way of telling you that for this section, the only answer or only value will be a specific number. It's not going to increase or decrease on that interval. It's going to stay constant for that section. So the example I gave you first is the greatest integer function. So this just says from 0 to 1 is 0, 1, and then you can go in the negative direction as well. So from -1 to 0 is -1, from -2 to -1 is -2. And that's all this is saying. And again, to make it a function, you have to make sure one side has a closed circle and one side has an open circle. This is your x, y. So the way these can come up in real life or can be helpful is one example, if you wanted to mail a book that is 3 pounds, you can use this graph to do this. So they use the mailer amount as an example because they say anything less than a pound would only be $1. Anything less or 2 pounds or less would only be $2. So you can use this graph. So instead of paying per ounce, you can pay for anything that's over this interval has one set cost. So the price to mail is on this side, the weight is on this side. If it's 3 pounds, I'm going to go to 3 pounds. This is the amount I'm looking at. That's $3. So the price to mail one book would be to mail a 3-pound book would be $3. So we'll practice this some more in class. Make sure you write down any questions, comments, or concerns you have so we can go over them together.